What we did in the last video was we went from the code for the factorial function, this f function right here, over to the recursion general form, the general form of recursion. So what I have written here is the same f function that we came up with last time, except I've made it a bit more verbose. I've put some more variable assignments in it. It still does the same exact thing as the code we wrote out in the last video. I have just assigned more variables and made it line by line just to make these steps look easier. And so again, in recursion, we make our input smaller. That would correspond to this step right here of setting this variable m equal to n minus 1. We solve the same problem on the smaller input, and so that would correspond with this line right here of setting f of m equal, or assigning f of m to this answer underscore m variable. And then this third step is to use our answer here, this answer m, to arrive at the solution to the original problem. So that corresponds with multiplying our answer to the smaller problem by n. So that's in this third step right here. So that gives us our final answer, which we returned. So what I want to cover right now is I want to look at the runtime. I want to look at the runtime for a general recursion method. Let's look at runtime for recursion. So before we figure out how to get the runtime from recursion, let's first define a function. And here I'm talking a mathematical function, not some code. We're going to define a mathematical function called t of n. What t of n means is t of n is the runtime for the code function f on an input of size n. So what might be a bit confusing is we use this function word in two different contexts. Here, f is a function or a method in terms of code. Right? We use the def keyword to define a method in code or a function in code. Here, this big T of n is a mathematical function, something like y equals x or y equals x squared, something like that. And so this big T of n is the runtime for our code function f, how long that function takes on an input of size n. And just for future reference purposes, here we mean size. It really doesn't matter for the purposes of factorial. Whatever our input is, whatever we want the factorial of, that is the size of our input. But if we were to have a function where the input is something like an array, the size might not be the contents of the array. It might be the size of the array itself. Nevertheless, we'll delve more into that in future videos. No need to worry about that too much right now. And so what I'm going to say is that the runtime for recursion, this big T of n, is made up of 3 parts. This big T of n equals the runtime to do that first step, which was making our input smaller, plus the runtime the second step, the time to solve the same problem on the smaller input, plus the runtime for that third step of taking our answer to the second step, taking the solution to the problem on the smaller input to arrive at the solution to the original problem. So that corresponds right here with the runtime to do this step plus the runtime to do this step plus the runtime to do this step. And so in essence we're saying, hey look, we defined a recursive function. We defined recursion as these 3 steps. And so our runtime for recursion is obviously going to be the time to run each of these steps. So what you might see in some textbooks, or at least how it's done in 250, is you're going to see that the time, the runtime, big T, is equal to D plus R plus C. And these have a one-to-one correspondence with this one, and this one. And so what I mean by that is that D stands for divide, which is the runtime for step 1. R stands for recurse, in other words, the runtime for step 2. And C stands for combine, the runtime for step 3. This formula means the exact same thing as that formula. It's just another way of writing it.